Nice to see everyone. I realize it's the post-lunch slump on the second day of the conference. People are probably tired, so I will try to do my best to keep this interesting and engaging. So great to meet everyone. My name is Reece Griffiths. I'm now the Field Chief Technology Officer at Collibra. But a bit of background on me. So I was very recently a founder. I was the founder of a company called Deasy Labs, which was a company targeted at making unstructured data ready for AI. And a few months back, we were acquired by Collibra. And for anyone who's not familiar, Collibra is one of the global leaders in data governance to bring in this unstructured data technology into the Collibra platform. So what we'll be talking about today is the topic of unstructured data and how through kind of the latest and greatest of AI technology, we can turn that unstructured data into AI-ready data assets. Okay, so firstly, what do we mean by unstructured data? So historically, the entire data governance industry has been focused on databases and tables, primarily structured content. The reality is that in the enterprise, more than 80% of data is unstructured. So we mean PDFs, PowerPoints, call transcripts, email chains, JPEGs, PNGs, CSV files. Most of this data historically has received no attention from a governance standpoint. And recently, with the rise of Gen AI, unstructured data has started to get a lot more attention. And our thesis was that for companies to win when it comes to AI adoption, they have to start thinking about turning this unstructured data into a usable data foundation. Today, this is the kind of reality for most companies. Unstructured data exists everywhere. There is no such thing as unstructured data quality. The dimensions haven't even been defined. And there is no contextual metadata, meaning that whether I'm a human or an AI system, I lack important context when I go through that content at scale. So there's a huge amount of time trying to find the relevant files. AI investments are wasted because chatbots are at 80% accuracy best. There is so much content that cannot be tapped into. And of course, there is risk around sensitive data, GDPR, and so on, given that we have never governed any of this content. So how do we think about moving towards an unstructured data system? So to draw a comparison, in the structured data world, we talked a lot about data products. Data products are clean, governed tables ready for typically AI and ML analytics. In the unstructured world, we're starting a conversation about knowledge products. Okay, so a knowledge product is the equivalent of a data product in the unstructured world. So what does this mean? We think of 4 criteria to define a knowledge product. We mean a file or a set of files that is pre-vetted for sensitivity, meaning can I use this data for my use case? Data quality, meaning should I use this data? Is it up to date? Is it duplicated? Is it low resolution? And importantly, it's enriched with metadata. And we distinguish here between metadata that helps humans find the relevant content and metadata that helps AI and agents to find the relevant content. And what's interesting is the taxonomies and the metadata that an analyst might find most helpful to go through SharePoint is not the same necessarily the same taxonomy as what an agent would find most helpful to go through a large body of content as part of a chatbot. So knowledge products are consumed by everyone. That was one of our big learnings when we started talking to companies about this theme. So for example, Lucy, a data scientist, her goal is to build a chatbot on top of some content in her SharePoint. So for her, a knowledge product means, how do I quickly filter through the thousands of files that exist across SharePoint, S3, across my Google Cloud storage? How do I find what files are relevant? What files are up to date? How can I make sure there isn't sensitive data in here? And then how can I create a semantic metadata layer to represent that content without months of back and forth with subject matter experts? Conversely, for Frank, HR business analyst, he cares about going to a SharePoint or a Box folder, and in this case, quickly finding all of the employment contracts they have about people employed in APAC in the last few years, and he wants to see all contracts that have an exclusivity term. So turning unstructured data into knowledge products is kind of a relevant topic for anyone who is working with data. So for us, the foundational thing here is metadata, which is a term that's thrown around a lot. In this conversation, we're talking about metadata to be content that we derive from the data itself. So this doesn't mean who has access or what was the last modified date. It means going through very unstructured content and using large language models predominantly to pull out relevant tags, relevant attributes from that data. So metadata, if you can read this, can mean a few things. So it could be, what kind of sensitive information is in here, pulling out specific elements of PII, classifying a document using natural language based on, some criteria provided by a company, assessing the uniqueness score, completeness, timeliness of a document. It could be simply what kind of document is this? In this case, a life insurance claims processing manual. What business unit does it belong to? What regions are covered? But it could also be very contextual metadata that an AI would find helpful. So, for example, tagging all of the questions that a document can answer and attaching those to a document, very helpful for an agent. Extracting specific regulatory guidelines that are maybe mentioned in this policy. Having yes or no metadata, like, does this policy mention emergency sickness coverage, yes or no? These kinds of tags are incredibly powerful for a chatbot, even if they're less relevant for a human. So I just show this because when we're talking about metadata here, the essence of what we're trying to demonstrate today is using large language models combined with traditional machine learning to sift through the contents of your unstructured data and pull out very semantically meaningful tags that can be used for both governance and AI use cases. So when we think about building a metadata system, there's a few things that are important. So especially if you've attempted to use an LLM to extract metadata, you'll know that creating standardized, reliable metadata is hard. So the system has to be reliable. We need a way to create clean, standardized filters with human-in-the-loop validation of accuracy, traceability. Has to be multimodal. We need to cover the text, but also the charts, the images, the tables embedded in these documents. The metadata must be contextual, meaning that I don't want a predefined list of tags that I can use. I don't want to just use, simple regex patterns. I want to be able to define any metadata that's relevant for my data domain, for my use case, and extract that in a customizable way. Finally, it must be automated. And of course, this means, at a minimum, using AI to generate this metadata. But this also means having a system that, as new data is produced every day in the company, we are generating more and more metadata. A lot of companies invest, you'll bring in a consultancy and have a many-year project to tag huge volumes of data, but they never set up an ongoing system to tag that data going forward. Okay, so shifting to our approach to this, which again was a company that my co-founders and I previously built and is now part of Collibra, a new product that we're calling Unstructured AI. So unstructured AI, if you only take one thing away from this conversation, what we're basically doing is taking that sea of unstructured content that exists, and we are generating very meaningful structured forms of that data. And this is all, of course, as automated as possible, using a mixture of language models plus traditional ML classification techniques. Okay, so how does this work? This is the flow, and I'll kind of go through this, and I'll talk through a demo in this session. But what we're doing here is we're connecting to a range of different, mostly cloud-based source systems. So this could be a SharePoint, an S3 bucket, a Confluence. It could be Databricks. It could be a vector database. It could be, for example, a Postgres, a Quadrant. We're ingesting this data, which means we're doing some kind of OCRing and multimodal parsing. We are identifying where there are tables in a PDF, where there are images. We are pulling them out. We are typically using large language models to describe the images into text form. We're then building these kinds of taxonomies. And what this basically is a set of natural language-based tags. Okay, so I as a user can say, for the contracts, I want to pull out, key contractual terms related to X, Y, and Z. And I can define that in natural language. Or for a clinical trial document, I want to tag every clinical trial with what was the patient demographic that was studied. And I can define these tags in natural language without any limitations. I can build them into hierarchical structures, meaning that I can say, okay, I'm bringing in this massive data. I first want to know what type of document is it. If it's a policy, there's a certain set of metadata that's relevant. Whereas if it's a clinical document, there's a different set of metadata that's relevant. So we want to set up this kind of hierarchical tagging. We use LLMs predominantly, plus some smaller classification models to then generate very contextual metadata across all of the content. Using that metadata foundation, you can then start filtering your data and saying, okay, now I've cataloged everything. I have a use case where I want to see all of my supplier contracts, and this is a real use case. A food and beverage company, they wanted to see all of their supplier contracts that had an auto renewal clause that was going to be triggered in the next 30 days, and where there was an upcoming pricing change in the contract. They previously had like an army of legal experts going through every contract. We set up this metadata workflow for them so that now every contract that comes in automatically gets tagged with those attributes. So they can then very easily filter for those auto-renewing contracts that they want to cancel. And then we need a layer to maintain this. So we want to make sure that any new data being produced is continuously being tagged. We want to keep these taxonomies dynamic. So if we have a set of document types, and then a new file type comes in, we don't want to force it to an existing attribute. We want to say to the user, hey, you had a taxonomy of these 10 document types. We've just had a new type come in. Maybe you should revise your taxonomy. Last thing. And then we want to also push this to a destination. So a destination could be the original file source. We find a lot of customers want to keep the metadata next to the existing files. Okay, so if I go to my SharePoint, ideally I don't have to leave SharePoint. I can just filter on metadata that's there. Or if I'm building a chatbot or an AI system, maybe I want to push this metadata directly into a vector database to enrich my chunks of text, to improve kind of semantic search. Okay, so for the rest of the session, we're going to go through a demo of how this works in practice. And coming back to the problem statements I mentioned earlier, I'm going to use Microsoft SharePoint as an example because I think lots of people are familiar with the situation of having a lot of data in SharePoint, a lot of unstructured data in particular that hasn't had any good governance cataloging around it for many years. I'm going to target two personas. So the first problem is coming back to kind of Frank and Lucy. I want to go to SharePoint as a non-technical user, and I want to be able to just filter for the files for my use case. And then the second problem statement that we'll come to is, now I have a data science team building a chatbot on a subset of that data. How do we kind of go through this funnel of filtering for what's relevant, what's sensitive, and then adding some semantic layer to improve that chatbot? All right, so we'll go through each step. We have some videos of how the product does this in practice. I hope you guys can see them. I'll talk through what's happening in case it's not super visible. So step one, we're going to connect to a SharePoint. And when we connect, we're going to ingest the data, which means reading in every single file and basically creating a database in the background that doesn't have to be there forever. It can be deleted pretty much straight away, but a database that represents the text from every single file, okay? So this is our SharePoint. We have a series of PDFs, PowerPoints in here, no metadata. We're going to ingest these into Unstructured AI. And that's what you see here. So if I switch here, so this is now Unstructured AI. So you see we have a catalog of these files. Again, they're just, all you see is the file names right now. If I open this up, you see what we've done is we've OCR'd and we've parsed the document, meaning that we've broken it up page by page. We've identified tables and images in the document. We've described those tables and images in text form as well. And we've basically created a starting point for some kind of natural language metadata creation. So now we've got our documents there ingested. They're ready to be tagged. What I really want to emphasize here is we're using mostly large language models, some smaller language models and classification models to then go through all of that content and basically pull out metadata. And this is fully automated. So it's not based on keyword search. It's based on a model that understands the context of a file, going through and making some decision around what metadata should be extracted. So once you're in Unstructured AI, we then define tags. And a tag is basically a metadata field that we want to pull out. So when we add tags, there's three ways you can do this. So you can define tags yourself, which means you're going to provide natural language descriptions of what you want. You can choose tags from a library that we have, or we can actually use a model to suggest the best metadata from your corpus. So if we go to the tag library, some basic tags that we might want is, what type of document is it? Is it a policy, a contract? Is it a financial document? We might want to add a sensitivity tag. So we'll look at the content and say, does it have PII? Does it have PHI? Does it have financial data? And maybe we want the dates of the documents as well. When was this published? So we add these tags to our tree. We haven't created metadata yet, but we've just setting up the kind of the backbone of the tagging. We can make these hierarchical. So I could now say, okay, if the first tag comes back as a contract, I'm now going to build a nested tag. So if it's a contract, then I'm going to automatically run another tag. So the way we create tags ourselves and allow users to do this is simply through, again, free-form text. So let's say I want a field in my SharePoint that is going to be, a summary of the topic of every document. I create a tag here and I call it, primary topic. My description to the model is just pull out the primary topic of the document. The problem is that users are inherently very lazy and their prompts are very bad. So we auto-refine that prompt into kind of what we call a best practice classification prompt to a model. So what you'll see pop up in a moment is the before and after of that user prompt. So before, the user just said primary topic of the document. Now it says, primary topic is the central subject matter of the purpose of the document. Here is the classification criteria that you should look for. Here's how to think about positive examples, negative examples, confidence factors, and so on. So this is just a prompt refinement step to make sure that when you're using LLMs to generate metadata, you are using them in a best practice manner. Okay, so if I add this tag now to my taxonomy, what you see is we've now built the first structure for the tagging that we're about to do. So every file now that comes through our system is going to be tagged with these three things. So what type of sensitive data is contained, what kind of document is it, what date was it published, and if it's a contract, we're also going to pull out the topic. So now if I hit generate metadata, the blue button on the top, I can then start automatically tagging all of my data using this natural language setup. So when I do that, what we end up with here is a structured view of that unstructured data. So on the left here, you see all of the files, and along the top, you see each of the columns that we've extracted. So if we look at this file, for example, it came back as a financial document, it had sensitive financial data, and it was about a card member agreement. So these are now structured fields. If I click on this, I see a few things. So firstly, we actually generated metadata across every page of that document, and then we synthesized it to file level. And this is an approach we use to improve the accuracy. We also show where it came from. Where was the origin of that in the original document? And you can also see these scores here. So when we use LLMs to generate metadata, one technique we found to be very helpful is we force them to give evidence. And then we use another model to evaluate how good was that evidence based on what I was trying to extract or classify. And these give us kind of confidence scores in the LLM generated metadata. So you can then build a human in the loop kind of process to have that extra layer of validation on anything that is below a certain threshold. So at this stage, what we've done is we've connected to SharePoint, we've defined some basic cataloging tags, we've gone through every document, and we've extracted them in a fully automated way. So coming back to the first problem statement for this demo, we want to make SharePoint searchable. So within Unstructured AI, we have the concept of a destination. So once I've generated this metadata and I'm happy with it, and I can redo that process, I can now export it all back into my SharePoint. So right now we have no columns. So if I go here to the top and I go to export metadata, I can choose the system that I want to push this metadata back into. In this case, I'm going to choose obviously SharePoint, but it could be a different system. And when we do that, we're going to create 3 new fields in SharePoint: the primary topic of the document, what type of document is it, and what was the publication date of the document. So when this is finished exporting, I go to SharePoint, I now refresh my screen, and you see here that there are now 3 new fields in my SharePoint: topic, date, and document type. So I can now filter, for example, for all of my contracts that are about reseller agreements, and I find that data. This system can then be set up as an automated continuous workflow. So every day we scan SharePoint for new files, we tag it using a predefined taxonomy, and we push that metadata back into Microsoft SharePoint. The beauty of doing this and keeping the metadata with the original files is that this metadata now exists within the kind of Microsoft system. So whether you're building data loss prevention policies or you're using Microsoft Copilot, this metadata now exists as additional structured filters that can be used for whatever you're doing. Second problem statement. So now we're thinking more about the AI team and the data scientists. So the challenge here is, a data scientist is often tasked with building a system on some subset of unstructured data. There's a few things they need to do. They need to firstly find the relevant files, which can take many months. They need to make sure that they don't have any sensitive data in there. They need to then set up, let's say, a vector database containing only the relevant files. And then the third point is they often need to spend many months working with a domain expert to build out a taxonomy that best fits that unstructured data, because they themselves don't know the data domain. So now we're going to show how unstructured AI basically allows you to run through that kind of workflow and immediately set up an enriched knowledge base for a chatbot. So the first thing we're going to do, we've now built like the structured foundation of this data. So we know what type of documents we have, the dates, sensitivity, topics. So now we're going to start filtering for a relevant subset of files. And this is kind of where we start to get into this knowledge product territory. So if I come back to my, my metadata that I've generated, this is back in Collibra. I can now start filtering on these fields to find the relevant subset of files that meet my use case needs. So in this case, we can say, again, we want a chatbot on contracts from the last 10 years with no sensitive data. So I say document type here is contract and legal agreement, and I apply that as one of my filters. I then say that my date field, my publication date, needs to be at least 2015, because again, I only want contracts from the last 10 years. And then finally, I can say that, my sensitive data criteria is that obviously I don't want any sensitive data in here. So when I apply these filters, what I'm basically now doing is pre-filtering that knowledge base, could have been thousands or in some cases millions of files, down to the relevant subset of PDFs, PowerPoints, Word docs, images that meet my criteria. And the nice thing is if you want to go deeper, you can then create more criteria, more tags, and filter on them again. So now what I can do is I can create what we call a data slice, which is basically a slice of my data that meets these criteria. So we only have contracts from the last 10 years, and there's no sensitive data in here. And I can start building out different data slices for different use cases, for different consumers, depending on what they want. In this case, we just say, this is for a legal chatbot. This is the subset of files from the last 10 years that we want to use for a particular AI application that we're building. And in unstructured AI, all you'll see on the left is data slices. So we then have a library of all of the different data slices that we've used, and we can drill into them at any point and see the metadata conditions. Any new data that enters the system, if it meets the conditions for a use case, can be brought into that use case as well. The cool thing we can then do is instead of looking at our entire SharePoint, we can now change the data source to be just that relevant set of files for our use case. So if we now switch this from our SharePoint connector, we can now instead connect to just the relevant set of files. So what we're basically doing here is finding the relevant knowledge base for our chatbot. So now we have only 25 files that we want to use. Now, the next piece is we want to generate some very detailed legal metadata, but we don't want to spend months with legal experts. So what we do here is we use an ML clustering algorithm to basically derive the key themes from every document, cluster them many times recursively to basically come up with the best taxonomy that fits this specific corpus of unstructured data. So what you see pop up here on the screen is some suggested metadata attributes. So for example, agreement type. Is it sales, distributor, master service agreement? What contractual clauses are present? What contractual party roles are there? What was the dispute resolution forum? The governing jurisdiction? So without being a legal expert, I can then start generating a taxonomy that is actually derived from this data. So I'm not force-fitting a taxonomy now. I'm actually learning the best taxonomy from this specific corpus of data. And so these become very domain-specific tags. If I open them up, we already pre-generate the prompts to the models, and we also pre-generate all of the output values. So for this tag, is it termination, confidentiality, auto-renewal clause, and so on. So this step is really trying to bypass that pain point that a lot of AI engineers and data scientists have, where they spend many months with domain experts trying to figure out what are the best tags, the best taxonomies, and instead we learn this from the data itself. Of course, there's always a kind of human-in-the-loop element where you will want to refine those, check them, but it gives you a very good 80% day one answer. So once we again hit generate, we now go through and we create even richer metadata on these contracts. So instead of just document type, we now have governing law jurisdiction, the key contractual clauses, what was the party role in the contract. If we open up any one of these documents, what we see is not only the metadata at the document level, but again, we see the metadata across every page or every chunk of that document, which becomes very critical for like AI retrieval systems having chunk level metadata. Again, we can see exactly where in the document did that metadata come from. And all of this was generated fully through those natural language prompts. So what we've done at this stage is we've basically we've taken our SharePoint, we've figured out the relevant subset of files, in this case 10 contracts in the last 10 years with no sensitive data. We've now auto-generated a taxonomy of very legal specific metadata. And the last thing we're going to do now is just push all of that to a vector database, which for anyone not familiar, a vector database is kind of the foundation of any kind of, chatbot or type or retrieval system that you're building on unstructured content, where you need to represent your unstructured data in kind of, chunks of information. The challenge is that if you don't have metadata in that vector database, a chatbot is basically just seeing like walls and walls of text and trying to basically infer semantic similarity between the document and what a user is asking. Metadata is such a critical factor in making those search systems scalable and accurate. Think of it as, somebody going into a library where those books kind of have no tags, no categories or anything. And what we're doing with the metadata is we're going into that library and we're adding, what is the genre? Who is the author? What are the key themes mentioned? What is the sentiment? What year was this book published? So that when a question comes in from the user, instead of looking at that entire library, we can use those filters to quickly find the 2% of documents, in this case of books, that are actually relevant. And by reducing the search system, we can drastically improve the retrieval accuracy, especially as we increase the amount of data that our chatbot is looking at. So the last thing we do here is basically push all of this metadata into a vector database. So again, instead of the model just seeing this huge block of text, which is from a contract or a policy, when I scroll down, what I've now added in here, which you see in red, is basically all of this very legal specific metadata that we've now generated. Okay, these are file level and chunk level tags that basically contextualize that chunk of information. So that when I'm building my chatbot or when my AI system is going through this data, it first looks at all of the tags in red and basically can decide, is this a relevant chunk of information for what I'm asking? So that's kind of the summary here, right? So what we've done, and I know we have like 1 or 2 minutes, basically an end-to-end system where we connect into unstructured data, building taxonomies either from scratch or in a suggested manner, using LLMs plus ML classification to generate that metadata, slice the data, and then push the metadata to source systems. In Collibra, what we're now working on early next year is being able to bring that metadata also into the broader Collibra suite. So you can have one unified data catalog for structured and unstructured data, one data marketplace, data quality on both structured and unstructured data as well. So that's a kind of, I guess, a quick intro. Sorry, there's a lot of info there. I hope people were able to follow along. If you want to learn more, Collibra and my colleagues were at stand N68. So come chat with us. We can go through in more depth, show you a demo. We also have a Collibra event in London on the 16th of October for anyone who wants to join that in person. So yeah, I appreciate the time and attention and very happy to chat to anyone at the end who has questions.